All right. Hello. Sorry for the delay. There's been some weird connectivity issue here. I actually still need to track it down afterwards. It seems like, as usual, DNS is kind of misbehaving. So I've ended up having to hard code everything and turn off resolve these so that things behave for this live stream. Anyways, right. So the past couple of weeks, I spent quite a bit of time preparing NorthSec and then actually running everything on site. I did a previous live stream a few weeks ago that kind of went over the general infrastructure, kind of how things look like from an Incus standpoint, like how our main cluster and how all of that stuff works. What I couldn't show you was what's within this year's specific edition. Because, well, it didn't happen yet, and it would have been a massive spoiler for anyone who would participate. Thankfully, NorthSec was last week, so now we can go in and kind of show more of what's going on. The other thing that's kind of interesting is we decided not to close the infrastructure after the event, which means we still have, I think, around 30 teams or something that are still connected and playing. Which also means that we actually have the full, well, most of the full production load going on the cluster right now. So that's kind of interesting to show because most of the year our cluster is not particularly busy, but during the event it goes kind of crazy. So I think what I'll do first is maybe kind of just run you through what the NorthSec CTF kind of looks like from like a participant's point of view. And then go look kind of behind the scenes at how we were monitoring things, how we're fixing things as the event goes, and all of the stuff that's running on Incus itself. So first thing first, basically how that works on site is we have quite a big building with a number of massive rooms. We initially set things up for a conference for a couple of days, and then after that is followed by the Capture the Flag event. And obviously, from an infrastructure standpoint, the capture the flag is the heaviest load, most critical thing. When running the conference itself, I think we peaked at maybe around 250, 300-ish Wi-Fi clients, and we barely touched a gigabit of network bandwidth. So overall for us, not much load at all, which is good because it lets us find a few issues and really tweak things. So that's going into effectively conference is Thursday, Friday, and then going into Friday evening when people arrive for the capture the flag, the infrastructure is very solid and ready to accommodate that. So the way it works for the participants to the CTF is after registering and everything, choosing their team, a few days before the event, we send them credentials by email. Those are VPN credentials. We used to do OpenVPN for a number of years. Now we switched to WireGuard this year, which actually worked out really well. With those credentials, they can initially only access a single website, which is, I can actually load it up here, test.nsec, and it just tells them, hi, your VPN works and you are on in team so and so. In this case, I'm connected to the admin VPN. So being on the admin VPN just shows them an admin. But it will normally just give a team number, and that's how they can confirm connectivity. Everything else is initially firewalled off, and then we open things as the contest starts at 8 p.m. on the Friday. Once that happens, the usual thing they do is go on www.nsec, which is kind of just a bit of an overview of our rules, how to score points, where to go to, code of conduct, all of those kind of critical bits. Going on there, they also get if they haven't loaded it yet, they get told to load the root CA that we use for our website. So we effectively have our own internal TLD called NSEC and a secondary one called CTF for the challenges. So if it's .NSEC, it's infrastructure. You don't get to attack that. If it's .CTF, then it's part of the cloned CTF infrastructure, and you can go and do whatever you want against that. Some details on like what the DNS server stuff is, that kind of thing, if you've got any issues, effectively. Yeah, some of the rules, and then binaries to access our scoring system. So it's our own scoring system we wrote a few years back. It's written in Go, it's clustered, fully redundant, and can deal with quite a bit of load, but also a lot of kind of complexity we have for like when you score some specific points, it gives you hints for what to do with the next challenge, that kind of thing. So it supports all of those kind of features. All right, after that, what they normally do is they can access the scoreboard itself. So we'll actually see it live because it's still running. So we can see it here. Let's switch to live theme. So we can see we had 82 teams this year, and that kind of gets you the timeline for the event and how things look like. They can also look at the normal scoreboard, and we can actually see we end up with a tie for the first spot here, and the very close third. So that's pretty good to see. The other thing they can do is access the link called challenges, and that gets them to a very customized discourse forum that we run. And here you see the admin view, so it's a bit weird because I see every single team, but normally people don't see that. So every team has their own category effectively. You can see all of them here. And within a category, so if I take the test team we keep running, which is 000, so it's this guy. If you go in there, then we can see a number of posts, and those posts are either made automatically at the beginning or when the challenge opens, or as a result of you having scored some specific points. Everything is run within a scenario, so there's a theme every year. This year, the theme was effectively that the participants were supposed to attend a corporate retreat type thing over the weekend. But arriving at the retreat, they get told that actually, no, it's not a real retreat. The most important customer of their company needs fixing, as in the human being itself or themselves needs fixing, and they're gonna be shrunk and injected into that human body to go and fix a variety of systems. So that's why we've got things like retinal system, spinal system, all of that kind of stuff. So that's a bit of a wacky theme, but that's what we're kind of known for. Every year we go with something very different, and every single challenge is effectively themed to an extent to really kind of fit together and not feel like your normal kind of Jeopardy style CTF where you just have a bunch of categories and you just go for whatever number of points you want. Ours is really designed to be a lot more themed, to have a lot more kind of be a more cohesive, and also features a number of physical challenges kind of separate from the stuff you just have online. So that's what they kind of do. They go through that, they go look at the different challenges. They would normally get some basic instructions. They might get some links to a specific challenge or to a file they can download. Like in this case, one is a PCAP file that they can go look at. Is this one like a web thing? I don't remember. Some of them are web, some of them in this case like you need to connect over SSH. So there's like a lot of different things. As I mentioned, I think in the last time I covered NorthSec, one thing that kind of sets us apart from most other CTFs is just how much infrastructure we have. So instead of every team accessing shared systems and then the challenge designers having to be very careful so that one team attacking the challenge can't go and block other teams, in our case, everything is cloned. So every single challenge is just duplicated for every team. That means a lot of containers and virtual machines running, but that also means a perfectly fair, fair game for everyone participating. So let me see if we can find, let's get a spot one. I think immune system might be a web thing. Is it this guy? Just trying to find something that sends you to an actual challenge. Is this one? Okay, manage through an admin portal. Yeah, okay. So this one is a web challenge. Probably not HTTPS. Let's just try HTTP. Yeah, there we go. So this particular challenge is going to be some kind of web server of some kind running in a container on the clone infrastructure. So what I'm accessing here is just for my team, and we can see it's on the CTF TLD, which means everything is fair game. You can go and attack that in whichever way you want. The one thing we don't really tolerate is people trying to brute force the actual flag to actually make points. Like there's no point in like brute forcing the scoring system effectively. That's the only thing that ends up getting your access suspended for some amount of time. So that's most of what's going on. The actual CTF starts on Friday, 8 p.m. and goes until 3 a.m. Then Saturday we reopen at 8 a.m. It goes until 9 p.m. At which point we've got a bit of a social thing going on for a couple hours. This year we had like a costume contest thing followed by Hacker Jeopardy, so like a game show type event where we ask a bunch of geeky questions to teams, effectively. And then we were going back to the CTF at 11 p.m. until 3 a.m., then reopening at 8 a.m. on Sunday and closing the whole thing at 3 p.m. So that's basically the whole thing. It's pretty intense weekend. It's very long. And for anyone wondering, we did see teams actually do 3 a.m. and then being back there the next day at 8 a.m. On my side, running the infrastructure team, we don't actually have anyone who does the full length because that would be kind of crazy. So this year I was in charge of doing all the mornings, so all of the openings, and I had someone else handle the 3 a.m. closing effectively. And on our side, what it means for like opening and closing is we have a network ACL in Incus that we flipped, which blocks access to all of the challenges. And we also tell the scoring system to go in read-only mode so that nobody can even try to submit anything. At the beginning, I did mention that they have access through a VPN, and this year was WireGuard. One thing we do is before the CTF opens, they do have access to WireGuard from outside of the venue. So they can use that to test that their machine is properly configured. But once the CTF opens at 8 p.m. on Friday, we block access to the VPN from outside of the venue because we want things to be fair. We want teams to actually have all be on site, all be maximum of 8 people, and not like, try to send their credentials to someone in a different time zone to try and do challenges during the night or whatever. So we're quite actively blocking access and keeping an eye on things. So that's pretty much how that thing works. I've not participated in CTFs in a while, so I'm not going to go through any challenges or any of that kind of stuff. But there's going to be some write-ups published by a bunch of the teams. So if you're into that, you can go and read about it. What I can show you is more of the kind of behind the scenes of how that all looks. Let's start with our Grafana, because that's what we were spending most of our time on really during the event. So if I load that, we've got a custom dashboard that gives us an overview of everything that's going on. And let's do the past week. It's going to be a lot of data, but it's going to give us a good view of what's going on. Okay. So now it loads everything. We can see, so this is the on-site network. Obviously it stopped on Sunday as we tore everything apart, tore everything down. Here we can see a bit of network traffic. That was probably Wednesday. Then Thursday, is the 17th Thursday? No, 17th is already Friday. Okay, so there was like some traffic on the tail end of the first conference day. Then here we've got some traffic at the beginning of the second conference day, and then going until around 6 p.m. is when 7 p.m. is when we allowed people into the venue. So we can see that the traffic then goes up significantly. On the traffic side, we're just using Node Exporter with a 1-minute sampling rate. So we know that the graph is effectively wrong. We did see spikes going all the way to like 5 or 6 gigabit on the internet. But because of the 1-minute sampling rate and downloading that quickly, nobody actually sustained that for a minute so that it could actually register that high. So that's why we are getting like 1.2 gigabit-ish as far as the highest point on the graph, because that would be sustained over a 1-minute period. Then we can see that initially a lot of people arrive with their laptop, do their updates, install all their tools and stuff. So that's why we see the massive spike. Then the other 2 days, the traffic is quite a bit lower at just a few hundred megabits on the internet. Not that it really matters, like we do have a 10 gigabit link between the venue and our infrastructure in the data center. So people could hammer things quite a bit. Then we've got the actual traffic also triaged between the different networks we're running. So guest is what all of the participants were connected to. Admin is a secondary Wi-Fi that we use, which doesn't have any limits. So on the guest side, we limit every single person to 100 megabit symmetric, but the admin network is not capped at all. Same thing with the AV network, which is also not capped. AV has the extra permission to access their point-to-point network, which is used for AV equipment, like all of the sound system and cameras and stuff. Then we've got some of the stats here. We can see the number of clients on the Wi-Fi. So during a conference day, we can see here, second conference day, 222-ish clients, so not super high. I think we went a bit higher on Thursday, but the stats are starting to be missing here. And then people arrive at the CTF here, so we can see a spike at 8:15. I think we actually touched 8:20 at some point, so that highest point is probably 8:20. Then closed, like it's probably at 2 a.m.-ish, yeah, 2:30 a.m. is when we see a massive dip. And then we're mostly back to everyone present at around noon the next day. But we already had like 200-ish, I think, pretty early on. Yeah, 8:30 a.m. we already had 200. So it's been pretty good to see. And kind of here we see a dip, so that's when the social event starts, then goes back up afterwards, and then goes down at like 2 a.m. effectively when things start closing, and reopening on Sunday to wrap things up. So that makes sense. It's kind of what we were expecting. Then we've got clients by AP. So that was kind of interesting to see whether any one of our Wi-Fi's was getting overloaded. One of them kind of did. You can see it here. We had a spike to 105. That's normal. If you actually look at when it's timed, we'll see that this is timed whenever we're using the event room for, like, not for the CTF, but for either the talk show or for the closing ceremony. That's because this room was spec'd for the conference. So assuming just like if things running on like 4 APs for a room that normally would contain less than 200 people, so that was fine. But when doing the social event or the closing ceremony, we had everyone in there, so like 600 plus people. And that's why we saw some of the APs in that room then go and spike to 100. But during the CTF itself, everything was pretty steady at around, the peak being around 58 clients. So that was pretty good. The general rule of thumb on our side is 1 AP per 4 teams. Each team being 8 people, that's 1 AP per 32 people. And they usually have laptop and maybe their phone connected. So yeah, 50, like 40, 50-ish is perfectly fine. And we didn't see any obvious issues, slowdowns, or people reporting disconnections. So things have been going pretty well. For anyone wondering, all the Wi-Fi was UniFi, so we're using mostly UniFi 6 Pros, which did a pretty good job. And all the networking, like all of the switching gear, is all MikroTik these days. We used to be Cisco, but our Cisco models were starting to die one by one. And buying completely new Cisco switches was kind of way overpriced. MikroTik does a pretty good job, and we can manage it with Ansible, which is good for us. Okay, so that's kind of the Wi-Fi side of things. We didn't have to look at that too much because that's really the dashboard we'd use if anyone reported connectivity issues, and nobody did. That might actually have been a first. We usually always have something that's kind of messed up as far as connectivity, and this year everything just worked. So that was very good to see. Then we've got load on the infrastructure itself, so that are 6 different servers and the average load. It's pretty interesting graph to see, I guess. What we do a few days before the event is a number of attempts at creating the infrastructure, so copying every single container and VMs and stuff for all 82 teams. So we can see some of those resets. Like here we were running it, then here we see a big dip, so that's when we deleted everything because we were gonna make some changes. And then we did a new clone, and then we had some more issues, so we took it down. And then we did the final one, which has been running up till now. We can see it's obviously a bit jittery, but in general, the loads didn't really spike past like 45, 50-ish, which on servers that have 128 CPU threads means that they are effectively below 50% utilization. So that's been very good to see. That's actually the first year where we see that kind of thing. It used to be way, way worse. But this year is the first year where we're using Incus with the new NUMA placement logic. So our CPUs are AMD Epics 32 cores, and we've got 2 of those per machine for a total of 64 cores, 128 threads. And we've got them configured in what's called NPS4, so node per socket 4. Which means every quadrant of a CPU chip is now split in 4, and that matches the physical layout. So we effectively had 4 quadrants of 8 cores, 16 threads, and the VMs were being tied to a specific quadrant at startup time. And that means there is no scheduling overhead or anything because they are on effectively the dedicated cores and dedicated access to their memory with no cross CCD or cross socket hop whatsoever. So that really improves packing, that really improves scheduling overall. And the fact that we saw pretty much all 6 servers showing almost identical usage pattern was really, really good to see. Not something we're used to, and was good, massive improvement this year. So really happy to see that. Memory, not that bad, frankly. The machines are loaded with 1 terabyte, and we did have, I mean, in theory, we would have had about 800 gig per server that's allocated to different VMs. But then not all of them ended up using their allocated memory. So we ended up running quite a bit lower than expected, which is actually good to see because memory is the our most critical resource. So that means we can pack a few more things next year, which is good to see. So we were kind of averaging somewhere in like the 350 to 500 gigs of RAM, depending on the servers, depending on what's running on there. So that was pretty good to see. Ceph, the Ceph throughput graphs are just completely screwed up. That's a bug in Ceph, so I'm gonna have to get that fixed. We did try to work around it by pulling a different metric from the placement groups, I think, but that's completely broken, as we can see. Like we don't have terabytes of per second of traffic going on. I think at the peak we saw maybe like 1 gigabyte per second or something like that. We initially had a bug that was causing a massive disk consumption from VMs due to not having enough memory. When we were doing that, we had Ceph servers reporting 4 gigabytes per second of network traffic. That's a problem because that's literally how much we have. So each server is on 40 gigabits, so around 4 gigabyte-ish. So when we see Ceph using 4 gigabytes, it means we're completely saturated. So that got resolved, and we effectively went from an average of 4 gigabytes when that bug was going on down to less than 100 megabytes after the issue was fixed. So that's good. If you see massive IOs on any of your Incus systems, take a close look at memory consumption, because being very low on memory means that the kernel is gonna have to flush its page cache and therefore pull files from disk constantly, which can cause a lot of IOs. So that's usually something to kind of keep an eye on. Next up, we've got some stats coming from the scoring system. So it kind of gives us mostly number of requests and requests per seconds per team. So that's how we detect anyone trying to brute force us. We can see it here. Like we had some teams go in like the over 3 requests per second. Again, sampling rate is about 1 point per minute or something like that now. So they actually had spikes going way faster than that because we're pretty quick at reacting when we see it. So usually within, I don't know, 30 seconds max, the team is disconnected. So we did see a few teams kind of abuse it, and they got told not to do that. So that's good. We also do statistics on the DNS servers, mostly because it's interesting to see if they perform properly. So we can see here that we've done mostly cache hits, so that's good. They're properly caching. But that also is a way for us to check anyone trying to brute force the DNS. So we've got that TLD.CTF, and we've literally seen people try to brute force their ways through the entire TLD to figure out what the challenges are. That's kind of pointless because we literally link to them from the forum. So if we see that, we usually also disconnect the teams and go tell them not to do that. So that's this one is the DNS that they get for the VPN. Once they're connected over the VPN, that's the DNS for the rest of the traffic at the venue. So we've got 2 DNS clusters for that, using Anycast and some capable of handling quite a lot of requests. I think we saw spikes at around 1,000 requests per second, and that's no issue whatsoever. I think they can go in the tens, if not hundreds of thousands of requests if needed. Okay, then this web server stack, we're using HTTP proxy in front of Nginx mostly, or in front of Discourse in the case of the forum. So we can also see kind of traffic here on the different endpoints. Typically we see most of the traffic on 3W because that's the one that also does large file storage. And we did have a few files that were like multiple hundreds megs large. So that's that kind of spike we were seeing. like not bad, like 40 megabytes per second, assuming it's like single client or something like that. That's still pretty good. Database, we've got a central Postgres we use for all of that, all of our data. So we also can keep track of number of transactions and things. That's mostly to see if anything goes wrong. The biggest hitter would be Discourse, so the farm, because it keeps hitting the database constantly. And so we keep an eye on that just in case something goes wrong. Then we get to more specific things that are specific to our infrastructure. So one thing is we monitor the VPN connections. So it's effectively looking at the WireGuard status on our VPN servers and just doing some stats. So that gives us the total number of teams currently connected and the number of total clients connected. You can see that both are in the red now. Those numbers would be very concerning if we were at the CTF right now. Thankfully, well, we're not, so those numbers are not concerning at all. They're actually pretty high, which is 25 teams connected, 32 people connected in total. During the event, we did go all the way to the 82 teams connected, which in my closing speech, I pointed out is the first time ever. We've usually always had a team not show up at all, not connected at all, which was always kind of weird. So this year, everyone actually connected, which is good. And I think we touched 620, 630-ish people connected, which, considering that the total capacity was somewhere around 650, was very good to see. And we kind of have stats here with like number of people connected. Normally, it's impossible to exceed 8 because that's our team size limit. There's an exception, and I bet it's going to be team 82. It is. So 82 is a special team, which we call the underdogs, and that's where our volunteers and speakers and a bunch of like media and other people can participate, but obviously in a non-competitive way. And I think we issued something in the neighborhood of 30 or so VPN credentials for that team. So that's why this one we see exceeding the 8 people limit. All of the other teams behaved and never managed to exceed their 8 people limit. Then we've got what we're actually looking at all weekend. Right now, well, there's no data, so that's kind of disappointing. But it's a dashboard that monitors every single container, services, endpoints in all of the teams. It's got, I think it was like 10,200 or so checks that are run every minute and gives us an output there. And that's what we can do to immediately check if anything goes wrong. Let's take an example. So if I go inside of this one, so that's inside of our test team, and I pretend that there is a kernel bug. Okay, I think I can do this. That should do it. So that effectively just wrote into the kernel log something that looks like a bug. So it just shows bug test. And that should get detected within the next minute or so, and it's gonna show up on this dashboard telling us that, hey, there's something that needs to be looked at. So we're testing effectively ICMP connectivity, so we ping absolutely everything, but we also do specific checks. There you go. Team 000, container incus, service, kernel bug. For kernel issues, we detect bug warnings and and oopses, so that we get to know about those. Usually with kernel bugs, we don't have much of a choice but to go and restart things, except that in this case it's fake, so I can just flush it, and it's gonna go away. We only had one kernel bug. It was some kind of ZFS crash of some kind that affected one team, so we just had to restart that entire team's infrastructure, which took 5 to 10 minutes, and we're good. Because there's like challenges are a bit flaky, let's be honest. They're developed pretty quickly by change designers, not always tested for the greatest stability, and then you've got participants trying to beat the crap out of them to try and find bugs. So we often see challenges go down, services go down. In general, everything runs in systemd with retry loops so that it just goes back up automatically, but that's not always true. So instead of just looking at that list and playing whack-a-mole and just restarting things constantly, we actually automated that this year. And if I go onto the right shell, let's see. So I want main shell. There we go. I'm getting my password. Okay, copying that. Okay. So if we go into our shared infra account here, there we go. We've got a script here called David, which we can run even in automated mode, and it just keeps an eye on the Prometheus data and automatically restart things. The joke behind the name is that we have a member of my team, the infrastructure team, called David, who sadly couldn't be here this year due to work travel, whose usual activity for the entire weekend is to keep an eye on things and just restart them as they go down. So as a bit of a joke, we just wrote a Python script that effectively does what it normally does, look at the different challenges, and then it's got a bit of a mapping table in there that tries to figure out what to restart and then goes and restarts it. So just that effectively kept things going pretty steadily. We also get a few more metrics from the challenges themselves. So we get the load. We had some folks kind of start fork bombs by accident or not, I'm not sure. So we had to go and kill things. A load of 114 is not super concerning. We do have process limits everywhere, but it was showing a few containers that were going a bit crazy. Disk usage, kind of same thing. Like we have one team here, team 56, that's using more disk than the rest. But we have to realize the scale. Like most of them are using 29.4-ish of disk space. And that team that's got a crazy disk usage, they're using 30. So it's not really concerning at all. And that's something we're actively trying to fix. Kind of same thing with memory. We've been kind of keeping an eye for if anyone suddenly exceed things. We did see that once with, I think it was around here. Yeah, this guy, team 13. There was a challenge built around Elasticsearch, and they did some kind of query that quickly used an additional 3 gigs of RAM. So rather than have that challenge potentially crash on us, we just went and restarted it, and that resolved it for the rest of the weekend. And yeah, that's basically it for our monitoring. Like that's the kind of thing where we've been doing this 12 years now, and infrastructure kind of has been changing from year to year. We obviously started with LXC, moved to LXD, now moved to Incus. We used to run container only, directly on bare metal. Then we started doing a bit of VMs here and there, some on-site, some off-site. Our servers have also changed a lot from donated hardware to a few cheaper Intel-based servers we bought a few years back, to what we have now, which is like pretty decent, even if they're now a few years old. AMD EPYC servers with a lot of memory and a lot of we're 1 terabyte of RAM per server, NVMe only storage, 40 gigabit network per server. They're pretty decent machines, which has solved a lot of issues. So things have evolved a lot year to year. So has our monitoring. We used to be relying on Nagios. These days, we've got everything in Prometheus with Grafana on top of it. And we could do alerts, but we're not. We usually just run the dashboard on all of our laptops, keep an eye on it, and just react immediately. And that's been working very well for us. Okay, so now to go look at the Incus side of things again. Let me get a shell on one of the servers. That's going to be slightly better than doing remote access from here. So if I go on the first of our servers, there we go. Okay, all right. So we can check like the load, as I said, is pretty low. If we look at what one of those servers does, we're gonna see a lot of VMs running. I'm actually wondering how many QEMU are running on one server here. 129. Okay. So yeah, if we look at the load, you can see the 128 threads are all busy doing stuff. The swap has been used. That's fine. That's what swap is for. But we still have like 400 something gigs of RAM available, so nothing to be concerned about. Now, I showed you that list last time around, which is the list of projects that we run. We're going to be creating 2025 shortly. And that list, well, last we looked at it, this particular line, I couldn't show you the details, and it only had, I think, 9 or so instances. We can see that we've got a lot more of that right now. That's because we've run the clone. So if I go and do a list, we're gonna see a lot of things in there. It takes a little while because, again, lots of things. There we go. So we can see it just repeats itself. So at the bottom, we've got something called team org. So those are the initial instances that we've set up throughout the year. And as we get close to the event, we effectively have just a single snapshot per instance, which is called clone. And then that snapshot is used to create everything else. And we've got a simple mapping. So effectively there's 14 teams per server. Their VPNs are going to be on the container on the same server. That's basically how we roll. So if we can see team 00 is on it, team 1 is on it, team 2 is on it, etc. You might notice we don't have IPv4 and IPv6 details. That's because since this is potentially a hostile environment, we don't trust the guest agent. So our statistics are effectively turned off, which means we don't get to know the IP addresses, but that's fine. We actually, we know how we numbered our things. We know how to find those addresses if we need to. The agent is still running in the VM, so we still get to actually interact with the agent in there. We just don't trust it for metrics. So that's a whole lot of them. None of those are actually snapshotted at all. We can easily destroy and recreate them if we need to. And we actually do that through separate tooling that we wrote a while back. So if I go here, I can see got a number of tools here. So there's some basic things we use for backup and the like. That's fine. But the tools that are kind of interesting are those. So we've got CTF clone, delete, patch, push, reset, run, start, and stop. So clone, what it does is it will take the org containers or VMs and then goes through the list of all the teams and goes and creates them all. If they're already created, it won't do anything, which means we can go, if we need to reset something, we can just delete a single VM in the list, rerun clone. It's just gonna go and backfill that one thing that's missing. So that works pretty well for that. CTF delete deletes all the clones. So that's what we're gonna be doing once we've closed remote access and we just need to archive this here. We're gonna be effectively deleting everything by running that one. Also during the initial stage where we do a bunch of tests, then I do CTF clone, CTF delete, CTF start, and then delete, well, CTF clone, CTF start, test my stuff, CTF delete, and repeat for a few days until I'm happy with the result. Patch, push, reset, and run are all tools that are actually made available to our staff. So not just the admin, not just the infrastructure team, but the rest of our the rest of our challenge designers, because they're used to fix things in place. So CTF patch, what it does is it takes the name of a challenge and a shell script, and it's going to use Incus. It's going to make it's going to do a few things. It's going to stop the challenge. It's going to restore it to a clean state, so effectively getting it back to how it was at the time it was started. Then it's going to run that, start it back up, run that script, and then make a new snapshot. The idea there is that we can effectively run the exact same fix for every team and have the exact same result at the end, because we've cleared any state changes that the participants might have caused. CTF push is just to push a file to a given container across all of the teams. CTF reset, that's a per team one, so we would just give it the team name and the challenge name, and it's gonna go and restore the container to its latest snapshot, effectively clearing anything that the team might have done to break it. And CTF run is a way to run a specific script just on a specific team. So that's what we use really for kind of patching things as we go. Because as you can imagine, if something is wrong in a challenge, we're not gonna go and fix it manually 82 times. Neither are we gonna be wiping everything in and redeploying. That takes too long. So we've got those tools to do fixes as we go during the event. And they're not particularly smart. Like we can probably make them smarter. But we effectively have a file that lists all of the teams, their VLAN number, and what machine they're supposed to be on. And that's what all of those scripts then consume to figure out what should they be talking to. One thing I didn't really show is, so when I went to the list here, you can see all of those VMs, but you don't see any containers. And I said that we're running pretty much everything in containers. That's because every team has that Incus VM. So if we go in there, it's kind of Incusception, because we've got, this is an Incus system itself, which then runs all of the containers. So when we do like CTF, like those CTF commands to patch something, reset something or whatever, it doesn't talk to the main Incus cluster. It actually talks to all of the individual Incus daemons for each of the teams. And we do that mostly because we don't, like it would be kind of neat in theory if we could do one project per team and then have a way to clone an entire project, but we don't have a good way to do that. So instead, we're using this approach of having all of the containers shoved into one VM, then a number of VMs per team, and cloning those within a single project. There's some stuff we might be able to improve in the future. Like it would be kind of neat to not have to deal with two different Incus endpoints, one that's team specific and one that's global. But for us, it's way better than we used to have, where we used to actually have 4 or 5 different deployments. So this year is actually a big improvement for us. And that's pretty much it as far as how we run this stuff. It is pretty, like, usually we have a pretty long list of issues and things to improve, and like we've done a lot of improvements in LXD and then Incus to make it really behave nicely for those kind of deployments, because we used to consider NorthSec as like being one of our largest, artist densest deployment. Like it's just 6 servers, so by cluster standard, it's not huge. But running something like what's the actual instance count right now? If we do all projects, CSV list name, give me the full list. There we go. Yeah, so we're running 954 instances across 6 machines, which is still pretty dense for servers of that size. Like we've seen people run more, but those VMs are also very, very busy. They're not empty web servers doing nothing. But we are at the point where this basically just works. I think it's the 2nd year now in a row where my closing speech, where I usually go through everything that burned and went up in flames during the weekend, is, well, actually no, things pretty much just worked. This year we had some firmware update issues about a week before the event. That was a bit nerve-wracking, but managed to get that fixed by showing up in person at the data center and fixing it. And we had that one team that ran into a ZFS issue, which was only really visible because it got us stuck when we were trying to patch all the teams. It tried to do a snapshot restore on that one team and got stuck. That's the only reason we haven't noticed it. Otherwise, it would probably have been able to keep going for the rest of the weekend. So things effectively all worked. Load was low enough that we could do other things. Managed to like put some firewall rules in place. Didn't go quite as crazy as last year, where we were literally upgrading production services from one version of Ubuntu to the next during the event. But we could have, like, there was literally nothing problematic, nothing bad there. Like we had some issues in the past with like gathering that very large number of metrics at once. We were hitting timeout, we were hitting issues, like slowing down Incus, causing a lot of database queries, that kind of stuff. None of that happened this year. There was no deadlock whatsoever, not seeing any kind of elevated CPU usage or anything. I think we noticed that Incus was a bit high on resources. Let's see if it's still the case. Yeah, so that's an issue. Like Incus is consuming a mostly insane amount of memory. So we need to sort that one out. But it's also been running through something like 6 or 7 clones. So 6 or 7 times where we literally created, started, and threw away 800 VMs. So I'm guessing some of that is still like didn't get fully flushed. Yeah, there we go. So we can see that Incus is using 756 megs of resident memory. That's about 5 times more than I would expect. It's not particularly concerning when you compare to other systems. Like, you know, if you're looking at VMware or something that's going to be using gigabytes. But for us, that's not normal. We normally expect Incus to be more in the 150 megs to 200 megs range. So the good thing is that everything is still running and we can easily do debug in place. So we're going to be able to track that one down and fix that issue for everyone. It's also possible that this one is higher because it's the database leader, is it? It is the database leader, okay. So it could actually be interesting to check on one that doesn't have any database role. So let's do 6. I want to see if it's database related or if it's something else. I'm actually kind of hoping it's something else because database memory issues are a bit of a pain to debug. But let's see. So Incus T. Okay, this one's using a lot more virtual memory, but that doesn't really matter. Virtual memory doesn't really count. What we care about is resident. And for resident, we're seeing kind of similar amounts, close to 700 megs. So yeah, that's gonna need to get debugged. The good thing is, yeah, we've got a debugging endpoint through pprof, so we can pull the full memory allocation profile and then try and sort out where that came from, what's holding that memory, and sort that one out. But yeah, that's usually what we were really using what we really liked with that kind of event was the amount of data, getting into some bugs and really optimizing the heck out of it. At this point, it kind of works too well. I mean, I'm not gonna complain that my weekend was comparatively quite easy, but also made for a bit of a boring closing speech, not having any interesting tidbits to report or bugs that needs to be fixed because we just discovered them due to the sheer scale of what we're doing. So that's basically it. What are we gonna be doing next? Well, we're going to be creating the 2025 infrastructure. We're going to be giving access to change designers, and they start preparing the next year. On our side, we want to try and automate more things. All of our infrastructure bits are already all in Ansible, but we want to start and automate some of the challenge infrastructure as well to also be in Ansible. So we've got a bit less work to do, especially around monitoring and things the week leading to the event. It's always a bit of a rush job last minute to get the monitoring up and running. So if we can have it set up from the beginning, that would be pretty neat. And so we want to get that into Ansible. The other thing that's still very manual for us is DNS. We've got all of our DNS records on Samba. And because this year we moved from traditional networking over to Oven, all of our IPv6 addresses changed and our DNS is completely out of date. I did fix a bunch of records that were needed for our monitoring, but I know there's a lot more that are completely wrong. And instead of dealing with that by hand, what we're going to be doing is the same thing I've done at home, which is using Incus network zones so that Incus itself exposes all of those DNS records and we don't need to go and maintain them by hand. So that's going to be a pretty big quality of life improvement for us. We also have a bit of a weird setup where our public DNS servers are not on our own infrastructure. They're still on my personal stuff instead of on NorthSec. So we're going to be also moving that back. And I think, yeah, one of the big things for this year is going to be just reworking how we do DNS and simplifying things. Other than that, well, I guess we'll see what else comes up on the Incus side. But things basically just work. We could do another year of that. One thing that was unusual this year for us was that none of the VMs were Windows. So all of the VMs we ran, again, if we go look at the specific teams, I'll take Underdog, so 82. No, I'm no longer on my usual machine, so that one doesn't use the right project. There we go. So if we look at a specific team, we can see Incus is obviously a Linux box, but so are all of the others. They were effectively part of a blue team track, and so causing log events going into Elasticsearch. All of those were Ubuntu VMs. They needed to be VMs due to the Elasticsearch agent requiring kernel access. But yeah, there was no Windows this year. That might also explain why we've seen that little load. Like in general, Linux systems tend to be less resource intensive than running Windows. So we'll see what happens next year. I think there's a lot of interest in getting a Windows track again. So there's a good chance that next year we're going to have more Windows VMs. We're going to have to deal with that. But we've done it in the past. We used to have a bunch of Windows VMs last year, and things have generally worked pretty well. So kind of not really seeing any issues there. And that's basically it. Hopefully this was entertaining, interesting. I don't know, I was gonna open the website, but I don't actually have it open. It was quite an interesting event for us. Always a good way to kind of showcase what Incus can do, kind of stress test things and play with new features and new things every year. So looking forward to next year. Gonna be like, we already have some tickets up for sale for next year, and we're gonna be announcing a lot more, like with final dates, all the sponsoring stuff and all the details in the next few months. On my side, gonna be back, like that was taking a lot of my time, so now I'm fully back to Incus. I've got, I think there's a release coming up next week. So Incus 6.2 is going to fix a lot of things, also include a lot of changes that came from the students at the University of Texas in Austin. Still got a few PRs for some of that student work to review and merge, but getting there. And I think we've got pretty much all of the bugs that kind of matter now fully addressed. So yeah, very happy to be back to Incus. With 1.6.2 is kind of out of the door, that should let me go back and focus on some of the larger features. Some of the things I'm looking forward to looking into are the OCI container story that I mentioned a few times. So we're gonna finally start working on that. And also working on more storage related things with a linstore driver. And yeah, that's it. Hope you enjoyed that. If you got any questions around any of this, feel free to leave them down below. This is not necessarily the best case for going on the community forum because it's a bit weirder. It's kind of like a big Incus user. So just leave them down below. I'll keep monitoring YouTube and so there. And otherwise, well, I'll see you next week, most likely with a release video instead of a live stream, but maybe I'll do both. We'll see. It's going to depend on how busy I end up being. Have a good one. See you in the next one. Bye.